and welcome to Mapinator. Mapinator is a web-based application delivering procedurally generated city maps for a whole host of users, such as game masters to run sessions with, writers to plan stories with, and hobbyists and world builders alike to use as a tool in their work. Mapinator allows users granular control over the generation parameters and a whole variety of export options, further enabling our users to add us to their toolkit and their existing workflow. Now, you may be wondering, what is procedural generation? Ever heard of Minecraft? Mapinator uses the same Perlin noise generation algorithm to create mathematical noise that is then used to create the basic landscape the app builds your city on top of. While a variety of map generators already exist, Mapinator distinguishes itself by being the only map generator aimed at replicating full-scale, modern-styled cities, as opposed to the others that are aimed at more fantasy and medieval styles. Ready to learn how it works? Let's turn things over to my partner to explain the generation process and show you how it's done.
The map is generated from the ground up, starting with the terrain. Before we do anything, we must generate a height map using Perlin noise. These randomly generated values are the foundation for the whole map. We start off with the elevation. High elevation is indicated in dark green, while low elevation is light green. We then generate bodies of water, and the lakes will gather in the largest basins on the map. The rivers will flow from high to low elevation, often connecting mountains and lakes. Next, we generate a majority of our roads, starting with highways. The highways connect the edges of the map. They try their best to avoid obstacles such as steep terrain and bodies of water. They also try to connect what we call anchor points, which are just points of interest on the map, such as downtown and bodies of water. The highways need a way to steer around obstacles. That is where our pathfinding algorithm comes in. We use A-star pathfinding to find the most optimal path around the obstacles. For example, we use pathfinding to steer around this lake instead of going right through it. We use similar logic to generate major roads. In this case, we are connecting the edges of the map to downtown. We also want to provide on and off ramps to the highway for efficient city navigation. Lastly, we want to place downtown in a way that makes sense. We want to put it in a place that's not too steep and fits on the map nicely. We can then draw a grid over downtown to best represent the most urbanized part of the map. Believe it or not, most cities are divided into zones. Zone placement depends on proximity to roads, downtown, bodies of water, and more. Agricultural zones are green. These zones are used for farming and livestock production. They tend to be in more sparse areas towards the edges of the map. They also need to be somewhat near water. Commercial zones are purple. This is where most businesses are, places such as malls, restaurants, and grocery stores. They need to be close to major roads and tend to gravitate towards the more dense areas of the map, usually the middle. Industrial zones are red. These are the factories. They need to be near a highway for easy transportation, but far enough from dense urban areas to not be disruptful. Lastly, residential zones are pink. These are houses and apartment complexes. They occupy a majority of the map and fill up everything else. We're almost there. Now, we can finally generate buildings. We take our road network and turn it into a planar graph. We then subdivide the faces of the planar graph with minor roads. We recursively divide these new faces into parcels. We can then add the buildings to each parcel. The number of buildings and the type of buildings per parcel depends on the zone that parcel is in. We're finally done. That is how you procedurally generate a city. Now that you understand what is happening, let's take a look at our site and see it in action. Here is mapinator.net. When you first enter the site, a random map will be generated for you. As you can see, this map has buildings, lakes, roads, and more. If you zoom in, you can see the buildings in more detail, just like Google Maps. If you zoom all the way out, we can see the whole city. I wonder, how big is this city? Let's learn more about it. If we expand our sidebar, we get some more options here. In this tab, we can see the answer to our question. Approximately 17,000 square meters. Fun fact, that is around the size of Salt Lake City. Below that, we have a resolution, which we can change. Higher resolutions show more detail, but take much longer to load. As you can see, the map is much more flushed out. Lower resolutions are a quick way to get a general idea of what the map looks like. The quality isn't as good, but you have a good idea of what's going on. Moving back to 256, You can also see the current seed we are in, and you can specify whatever seed you would like. The other tab has some more map-specific parameters, such as the number of rivers, lakes, highways, the size of downtown, and the distance between the waters and roads. You will note that these parameters serve as a maximum. We won't be able to get exactly the number of rivers, for example, that you may want due to the nature of the seed. Let's change the number of highways. Let's say I don't want any highways on my map. As you can see, my highway is gone. Lastly, we can export the map. We can choose between JPEG, PNG, PDF, and SVG. Let's save this as a PNG. Great! Now I have access to my map, and I can share it with my friends.
Mapinator makes use of Next.js as a full-stack solution for creating a dynamic reactive website. We also make use of MapLibre, which is a graphical mapping library built on top of WebGL. Mapinator's generation logic makes use of a bespoke Perlin noise implementation to build our terrain. This includes the ground, the rivers, and our lakes. All randomness within Mapinator is seeded so every output is reproducible. We use our own self-hosted GitLab runner in a Docker container for deployment to Cloudflare workers. Additionally, all unit testing within Mapinator was done with Jest. Thank you for your time. We would like to give a special thanks to our capstone advisors, Dr. John Vergeer and David Bean, for their support and help throughout this project.